Alright, today we're going to learn how to solve rational equations. So we've talked about all the different types of expressions, and we've talked about how to simplify them all, multiply, divide, adding, and subtracting. So today we're actually going to do an equation. And I first want to talk about what's an expression versus an equation. An expression, there's more complexity to it, but an expression is something that has no equal sign, basically. Okay, so an expression is just where you're saying 3 plus x. That's an expression. Or 1/9 plus x over 5. Those are all expressions. You can even subtract. You can say 5x minus 3. That's an expression. There's no equal sign. An equation has the equal sign. Okay, and like I said, there's more to it. There's bigger definitions. There's whatever. But I'm just going to get down to the simplicity of it. So an equation is like 3 plus x equals 6. Or 7x minus 5y equals 3. Okay, those are all equations. Alright, so today we're actually going to do an equation where we've been doing the expressions, where we were just like simplifying one side. Now we're actually going to do an equation where we got to simplify both sides and solve. Okay, so steps. I try to make them pretty simple. Find a common denominator on both sides. This right here is basically you going back to your adding and subtracting rules, is what that means. So you factor, you get common denominators, all that stuff. So that's what that is. That's why I didn't feel like writing it all over again, because we've gone over those steps. We should have those steps memorized. After that, you're going to solve the numerator. Okay, you read that? Not the denominator. You are going to solve the numerator. Okay, for x. And remember how in the beginning of this unit we talked about extraneous solutions? Okay, that is where the denominator equals 0. Remember that the denominator can't equal 0? So you find out where the denominator equals 0, and if that is one of your x's, we're going to label that an extraneous solution. We talked about this, I think, when we were in logarithms. Remember, logarithms you can't take the log of a negative number. It was an extraneous solution. It's an answer, but it's an extraneous solution, which we'll look at the graph and I'll show you what that means later. So you have to check your answers. You have to, because if you write down one answer that's an extraneous solution, you're going to get it wrong. Okay, especially with Delta Math and Study Hour. So you could have 2 solutions, but then an extraneous solution will mark one out. Sometimes you'll have no solution because it'll mark both of them out, or one of them, okay? Alright, so let's start doing examples, okay? Alright, so number 1, start out pretty easy. X over 5 plus x over 2 equals 7. First, I'd look at my extraneous solutions. Well, there are none. Okay, you only have an extraneous solution if there's an x in the denominator. So there are no extraneous solutions. Okay, here. This one doesn't have one. So we put the 7 over 1, remember? Now, 2 can't go on a 5 and 5 can't go on a 2. But what number can they both be made to look like? And that's 10. So I need to make 5 look like 10. And to make 5 look like 10, I'm going to multiply it by 2. To make 2 look like 10, I'm going to multiply it by 5. To make 1 look like 10, I've got to multiply it by 10. So in the previous lessons, we only simplified this left-hand side. Now we're going to have to do both, okay? So I'm going to do this. That's 2. So that's 2x over 10 plus 5x over 10 equals 70 over 10. And when you have like denominators, which we do, okay, so when you have those like denominators, then you can come over here. You can come over here to the, and you can solve the numerator. So we're going to say 2x plus 5x equals 70. The denominators didn't go away. This is just how you solve it. Remember I've been telling you learn tools of how to solve your equations? Like when we solve logs and we converted a log to an exponential. Or remember when you had two logs with the same bases and we set the inside of the logs equal to each other? The logs didn't go away. It's just how you solve it. So the denominators are still here. This is just how you solve a rational, is you solve a rational by solving the numerator. So now it's like a linear equation. 2x plus 5x is going to be 7x. That equals 70 divided by 7. So my solution here is 10. And we've already checked. There's no extraneous solutions, so 10 is my answer. Okay? All right. Number 2. Let me mark off what I've done so I don't forget. All right, number 2 is going to be 11 over 3x minus 1 over 3 equals negative 4 over x squared. Now, you're supposed to factor. The last one didn't need factoring, okay? And this one technically doesn't need factoring, but we do know that x squared is really just x times x, right? So let's leave it like that. So now you have to figure out what all three bases are missing. Okay, well the 3x, it's got the 3, it's got an x, but it doesn't have two x's, so I need to multiply him by an x. He's missing an x. This 3 is no x's, and we need a total of 2, so we're going to multiply it by x squared. This guy, he's got all the x's, he's just missing a 3. So I'm going to have 11x over 3x squared minus x squared over 3x squared equals negative 12 over 3x squared. Now they all have the same denominator. We come over here. Now, extraneous solution. 3x squared, okay, well you have, so you go back to the beginning, so 3x. So 3x can't equal 0, so that just means x can't be who? 0. Your x squared can't equal 0, and that's also just a 0. So my extraneous solution here is 0. So my answer can't be 0, okay? It can be any other number in the world but 0. So now let's solve. So we've got 11x minus x squared minus 12, equals negative 12. Now, anytime you have the quadratic term, which is the x squared, the linear term, which is 11x, and a constant, you need to set it equal to 0 and factor. Put it in standard form. So it's going to be negative x squared minus 11x plus 12 equals 0. This, I'd go to Desmos and factor it. Okay? Let's see. So it's going to be negative x squared. So negative x squared plus 11x minus 12. Am I right? Negative 11. Oh, it's minus and plus 12. Is that right? No, that's a plus 11x. Okay. I thought so. Alright, so I'm going to zoom out. Then we factor by seeing where it crosses. So it crosses at negative 1 and 12. So that is going to be x plus 1, x minus 12. So this is going to be x plus 1, x minus 12. Okay. Now you're actually solving. So we have to say x plus 1 equals 0. X minus 12 equals 0. Solve it like you did in Math 2. Now, are any of those numbers 0? No. So, both of these are your answer. Okay? All right. Number 3. So number 3 is going to be 4 over x plus 2 plus 3 equals 3x over x minus 3. Now we're getting into the factor denominators, where it's like a factor. It's not just numbers. So basically it's going to be missing whatever factor it's missing. So like x plus 2 is a factor, x minus 3 is a factor, okay? So that's your common denominator, right? X plus 2, x minus 3. So each one of these are going to have this denominator. And you've got to figure out which one's missing what. Well, this guy is missing the x minus 3, so we're going to multiply him by x minus 3. You're going to have to distribute that 4 and get 4x minus 12. This guy's missing everybody. So he just needs, we're going to come over here to the side. Okay. I would box those 2 in and then distribute that 3. So you're going to get x squared minus x minus 6. Then distribute the 3 and get 3x squared minus 3x minus 18. Because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Okay. So this is now going to be 3x squared minus 3x minus 18. So we had to multiply him by both. Okay. Now this guy, he's only missing the x plus 2. So we're going to distribute and get 3x squared plus 6x. Now they all have the same denominator. We can bring down the numerators. And solve. Okay. Of course, we need to clean this left side up majorly. So let's start with standard form. So that's a 3x squared. 4x and negative 3x is an x. And then a negative 12 and a negative 18 is going to be a negative 30. And that's going to equal 3x squared plus 6x. I taught you, remember the trick I taught you? When you have the same thing, literally the same thing on both sides, we can cancel them out. So that gets rid of the squared term, so we don't have to factor this one like we did the last one. So now we just solve for x. Get your x's on the same side, so I'm going to subtract x. I get negative 30 equals 5x. Divide by 5. X equals negative 6. Now, you need to check that. Can it equal negative 6? Well, negative 6 plus 2. So if I was to plug negative 6 in here, is it going to give me 0? No, it's not. Okay? So, because your string of solutions here are going to be, so x can't be negative 2, because negative 2 plus 2 makes 0. And then 3 minus 3 also makes 0. So those are my extraneous solutions. So negative 6 is okay. Okay, you have to check your answers. All right. All right, so number 4 is going to be x over x minus 2 minus 7 equals 2 over x minus 2. Whole number, put it over 1. Now if you look, this guy and this guy have the same denominator. It's this one that's missing, that middle one that's missing the x minus 2. So actually, they are fine. We have to multiply this guy by x minus 2. Now, remember the keep, change, flip. When you have subtraction, go ahead and do that. Make that a plus sign. Do your keep, change, flip. Let me change my color. Do your keep, change, flip. Change that to addition, change his sign. So you're distributing that negative, and you don't have to worry about making a mistake, okay? So negative 7 times negative, so this is a plus now. Negative 7 times x is negative 7x. And then negative 7 times negative 2, that's a minus, is going to be a positive 14 all over x minus 2. Go ahead and get rid of that negative, okay, because it's going to cause you trouble if you don't, okay? So now that they all have the same denominator, now, what's my extraneous solution here? X minus 2 is my only denominator, correct? So solve it. So x can't equal 2, so we got to look out for that, okay? So let's solve. We got x plus negative 7x plus 14 equals 2. Clean it up. X minus 7 is negative 6x plus 14 equals 2. Solve. Subtract 14. You get negative 6x equals negative 12. Divide by negative 6. And x equals 2. But can x equal 2? No, x can't equal 2 here. It's an extraneous solution. So this is not an answer. And your real answer is no solution. Okay? So that's what happens when your answer is your extraneous solution. It is no solution. Okay? Because that is a hole in the graph. And we'll talk about that. It's not a hole in the graph. It can be in a hole in a graph. It's going to be a hole in a graph where it's going to be an asymptote, which we're going to talk about next lesson. Okay? All right. Number 5 is next. So this one's going to be 3 over x minus 3 minus 7 over x plus 3 equals 2 over x squared minus 9. So there's multiple things we need to do right now. We need to do our keep, change, flip, change subtraction to addition, and then change the sign of the next numerator. So let's just make that a negative. We need to factor this x squared minus 9. Okay, so we did our keep, change, change. Factor it. Well, 9's a perfect squared. So this is going to be x plus 3, x minus 3, but also Desmos would have showed you that, okay? So we factored it. So now, your common denominator here is what? Your common denominator is the combination of everybody. So my common denominator is going to be this. X plus 3, x minus 3. That's going to be my common denominator. And then we've got 3 of them. Now, the right-hand side, it has the right denominator, doesn't it? So we're just going to bring that one down because he doesn't need anything done to him. Now the x minus 3 guy, he's missing an x plus 3. So distribute, and you get 3x plus 9. This guy's missing the x minus 3. Distribute, and you get negative 7x plus 21. Okay? Now, your extraneous solutions. That is x plus 3 can't equal 0. So we subtract the 3. So x can't be negative 3. And, has another one, x minus 3 can't equal 0. So we solve it. So x can't be positive 3, nor can it be negative 3 as a solution. Okay? So now we've got that, we're going to come in here and solve. We got 3x plus 9 minus 7x plus 21 equals 2. Clean it up. 3x minus 7x is negative 4x. 9 and 21 is going to be 30. That equals 2. We're going to subtract 30. I get negative 4x equals negative 28. Divided by negative 4. X equals 7. So, is that an extraneous solution? No. So that is my answer. Okay? All right. 3 more. All right. So number... No, I don't number 1. Let's see. Number 6. Okay. This one's going to be 4 over x minus 4 minus 3 over x plus 1 equals 5 over x squared minus 7x plus 12. Alright, so I copied problem down wrong. So I paused it. That is what it's supposed to be. Okay, so we need to factor this, okay? And it's going to be x minus 4, x plus 1. Yes. All right. So this guy, left-hand side, has everybody, right? So your common denominator is going to be x minus 4, x plus 1. Okay. Plus, same thing. Now, the right-hand side, it has everybody, so we can just bring him down. Okay. Now, this guy right here, he's missing the x plus 1, so we're going to multiply him by x plus 1, distribute, and get 4x plus 4. This guy's missing the x minus 4, distribute. Now, extraneous solutions. Let's talk about extraneous solutions. X minus 4 can't equal 0, so x can't equal 4. X plus 1 can't equal 0, so x can't equal negative 1. So those are my two solutions that it cannot be. So we got to keep an eye out. Now that we've got the denominators alike, let's bring down the numerators.
Hold on, I'm gonna wash my hands.
Okay. Alright, so we're going to combine like terms. So 4x minus 3x is x. Plus 4 and plus 12 is going to be 16 equals 5. Yeah, so subtract the 16. So 5 minus 16 is going to be negative 11. So x equals negative 11. That is not one of my extraneous solutions. So we're good. That is an answer. Okay? Alright, two more. Well, let's do one more. Alright, one more. So number 7. Number 7 is going to be 3, let's do that one. 3x over x plus 2 minus 2 over x plus 3 equals 36 over x squared plus 5x plus 6. Alright, so we got to do two things here. Keep, change, change. Change, change. You need to factor this guy. And it's going to be x plus 3, x plus 2. Now, he's got what you want, the x plus 3 and the x plus 2. So we don't have to do anything to him. But we do have to do something to this first one. Right? It's missing the x plus 3. So distribute. And you get 3x squared plus 9x. Plus, this guy is missing the x plus 2. Distribute. Negative 2x minus 4. This guy's missing nothing, so we're golden. Now, extraneous solutions. X plus 3 can't equal 0, so x can't be negative 3. And then x plus 2 can't equal 0. So x also can't be negative 2. So you've got two things that it can't be. It can't be, oh my gosh. You know I can't stand that. So it can't be negative 3 and it can't be negative 2. Okay? Alright. So bring down your numerators. 3x squared plus 9x minus 2x minus 4 equals 36. Combined. Well, the 3x squared can't be combined, but the 9x and the negative 2x will give you a positive 7x minus 4. I told you when you have the quadratic term and the linear term, you have to set it equal to 0. So we're going to subtract the 36, and we get 3x squared plus 7x minus 40 equals 0. I'm going to write this down. So we're going to go to Desmos, and we're going to factor it. Okay. So we're going to say 3x squared plus 7x minus 40. And that's going to be x, oh no, 2.666, sorry, Nana. Ugh. So again, I told you, some people might look down on this, but special times call for special measures. So we go over here and we're gonna Google it. What fraction is 2 point? There you go. Look right there. So if you look, it says, Lord. So what we're gonna do is we're just gonna do the decimal. And I'll show you what to do. It's making it complicated. Repeating, that's what it was. It didn't have repeating up there. You gotta have the word repeating. Okay, so let's put the 2 back up there. If you don't have repeating, it's not gonna do it. You know it's repeating because it rounded that 6. So what fraction is 2.66666? 7 repeating? Let's see. Let me see what this does. No. Okay, so we're just going to do what I had done. So what fraction is that repeating? And it's going to be 2/3. See right there? 2/3. So it's 2 2/3. All right. So it's x plus 5. Let's go ahead and write that one down. So it's x plus 5. And then that's 2 2/3, right? So to convert that to an improper fraction, 2 times 3 is 6, plus 2 is 8, so it's 8/3. So that's going to be minus 8/3. So x minus 8/3, okay? Which, remember, you do the bottoms up, so it's really going to be x plus 5 times 3x minus 8. Solve them. X plus 5 equals 0, so x equals negative 5. That's not an extraneous solution, so that's right. And then 3x minus 8 equals 0. You add the 8. We get 3x equals 8. Divided by 3. X equals 8/3. Okay? So those are your 2 answers. Okay? Alright, so that's it for today's lesson. You're going to have a study island to do today. And tomorrow, you'll kill me because I'm going to show you the secret to solving these without all this. Okay, but today you have to do all this. Alright, guys. So have a good day. Bye.